Today is September 19th, 2011. Don't forget to sign up on the course tonight. We're on page 20 in your textbook. Okay, method of substitution. Last class we learned about graphing lines and finding the points of intersection by graphing. Today we're going to find points of intersection by looking at the equations and using algebra to solve. So the very first example in our book, they've given us our first equation, y is equal to negative x plus 8. And the other equation they've given us is x minus y equals 4. Okay, so we're going to be using algebra to solve these. First off, you need two equations, which we have, in order to solve anything that has two variables. Okay, we have a y variable in both and an x variable in both. If we had only one equation, say we only had equation 1, we would not be able to solve for both x and y for a definite number. Okay? Because we have two equations though, equation 1 and equation 2, we can find a definite number for both x and y. That point is going to be our point of intersection on a graph. So our x value is going to be the coordinate of x, and our y value will be the coordinate of y, and that will be where these two lines intersect each other on a graph. So, in order to do this, I need to set one equation equal to a variable. Okay? So we're going to start with equation 1. We'll do it in red. Y is equal to negative x plus 8. Alright, if you guys notice, equation 1 is already set equal to y. So you've made it very easy for us. I'm going to take equation 2, do it in blue. X minus y equals 4. Because I know that y is equal to negative x plus 8, I'm going to substitute in for the y in the other equation this entire two-term expression. So, what's going to happen is I'm going to have x minus, and I'm going to take this part here. Okay, I'm putting brackets around it so you know what I'm putting in. Negative x plus 8 and is equal to 4. So what I've done again is I've taken what y was equal to and I substituted in for the y in the other equation. So I now have x minus negative x plus 8. Okay? I'm going to simplify this equation for x now. So first off, I need to distribute the negative on the outsides of the brackets. So I'm going to be left with x. Negative times negative x will be plus x. And negative times positive 8 is minus 8. Equals 4. Whoa, that's not 4. I'm going to combine my like terms. I have x plus x, which will give us 2x. And I need to move negative 8 to the other side of the equation. So I will have 2x is equal to 4 plus 8. 2x is equal to 12. And finally, I need to move the 2 to the other side. And because this is multiplication, I need to divide both sides by 2. So I divide this by 2. And I get x is equal to 6. Okay, now what I've done is I've solved for x. So I have the x coordinate for the point of intersection. So I can put that in. X is 6. I know that value. Great. Now what I need to do is I need to plug in this 6 in for the x values. So I'm going to go relook at my first two equations. I can either plug it in for this x in the first equation, or I can plug it in for the x in the second equation. It doesn't matter. Okay? I'm going to go back to the first equation and sub it into that one. So we'll do that one in red again. We had y was equal to negative x plus 8. We discovered that x was equal to 6. So y is equal to negative. And I'm going to plug in the value of 6. If you guys notice, I plugged it in for just x, just like I plugged the other stuff in for just y. Plus 8. What this says now is y is equal to negative 6 plus 8. Y is equal to 2. So my point of intersection, if I were to graph these two lines, is exactly at 6, 2 on a graph. What's good about substitution is when we graph, sometimes we'll get decimal numbers or we'll get fractions, and it's very hard to tell when we're graphing two lines what that point of intersection will be. When we use the method of substitution, we're going to get exact numbers. So we might get, for an example, we might get 6.5 as one point and maybe 4.2 as the other. Substitution will give us exact coordinates for our point of intersection. Just so happened we got whole numbers for this one. Okay, we're doing example 3 from your textbook. Again, I have equation 1 and equation 2. I need to set one of the equations equal to a variable. Okay? So I'm going to look around. I can tell you from experience that it's going to be easiest if I deal with equation 2 and if I set it equal to y. Okay? So what it means is I'm going to set up equation 2. I'll write equation 2 in red. 4x plus y is equal to 9. I need to isolate y. I need to get it by itself, so I need to move 4x to the other side of the equation. Y will be equal to 9 minus 4x. Once I've isolated just y by itself, there's no number here like 2y, it's just y. I can then take this value, what y is equal to, and plug it into the other equation. So our other equation was equation 1, and we had 2x minus y is equal to 4. What I'm going to be doing is I'm going to be taking this value, these two terms, and plugging them in for the y in the other equation. So our next line will read 2x subtract 9 minus 4x is equal to 4, and I meant to write that in red for you. 9 minus 4x. Okay? So what I've done is I've taken this value and I've plugged it in for the y in the other equation because we knew that y was equal to that. Once I've done that, I'm going to have to simplify. Again, I'm going to have to distribute my negative sign. So I'll have 2x minus 9 plus 4x. When I distribute the negative, it switches the signs of the numbers inside. I'm going to collect like terms. So I'm going to move the 9 to the other side. So I have 2x plus 4x is equal to 4 plus 9. When I move the 9 to the other side, it became positive 9. I collect my like terms. 2x plus 4x is 6x. 4 plus 9, 13. And finally, I'm trying to solve for just x. So that means I need to divide, because this says 6 times x. When I bring the 6 to the other side, I'm going to have to divide by 6. So I'm left with x is equal to 13 over 6. So if you guys notice, like I said before, I don't have a whole number. You can write this as a decimal. Okay.
How would we place it on the trouble?
Okay, so for our point of intersection, we've already discovered the x value. The x value was 13 over 6. Now that I have that, I'm going to plug in x in the other equation. My other equation was 4x plus y equals 9. We're going to plug in for x our 13 over 6. So I get 4 times 13 over 6 plus y equals 9. I need to isolate for y. So this is a multiplication between two fractions. 4 times 13 is going to be 52 over 6 plus y equals 9. I need to move 52 over 6 to the other side. This will become 9 minus 52 over 6. I need to turn 9 into a fraction above 6 so that I can subtract my fractions. So I'm going to get 54 over 6 minus 52 over 6. And finally, y will be equal to 2 over 6, or 1/3, which is our y value. Our y value is 1/3. Yeah, we'll put the entire page up. I know I did that very quickly. Rewatch the video again tonight. Your homework is questions 1, 2, 3 from lesson 1.2. Okay? I don't know the page, but it's lesson 1.2, numbers 1.1, 2, 3.